So let's have a lecture on shapes. Okay? So siguro um, you may not remember it, pero ang isa sa mga una nating na-learn when we were young, although young pa naman tayo ngayon, or when we were like 3 to 6 years old, is how to recognize shapes. No? So yan yung mga unang-unang mga pinapag-aralan natin. And that's also one of the first no, na mga human activities or human endeavor na pinagtuunan ng pansin na pag-aralan itong shapes. And these shapes actually, people try to describe this in a mathematical way. In fact, meron siyang mathematical basis itong shapes. And we would appreciate more shapes if we are going to study it from a mathematical perspective. So for this topic, which is Module 6, we will study and trace the history of the study of shapes. Okay, so what are the learning outcomes? It's very important to know these learning outcomes because this will be used later as a benchmark or as a basis whether you have learned the objective of the module or the topics. So at the end of this lesson, you need to ask yourself, no, if you are able to achieve these learning outcomes. So what are the learning outcomes for this module? First one is should be able to describe the different types of geometries based on their axiomatic systems. Okay, what do we mean by axiomatic? Diba, na-learn na natin yan? Ano ba ang ibig sabihin ng axiomatic? Yes. So ano ba yung axiom? Well, start muna tayo sa axioms kasi, di ba gali, axiomatic. So it comes from axiom. No? Ano ba yung axiom? Actually, axiom is just state. Sa math kasi, sa math, you're familiar. Hindi kasi, when you say something, it's not enough that you say something. No, you need to prove it, right? So when you say that 1 plus 1 equals 2, it's not enough for a mathematician to just accept it as it is, right? So you need to prove it. And how do you prove it? That's using logic, right? So you try to prove the truthfulness of a statement by logic, correct? But there are some statements in mathematics which is obviously true, but there is no proof, or we cannot find a proof. Tama? So yan yung tinatawag natin na axiom. It is assumed to be true without proof. Okay? So, tinawag siya na axiomatic is because there are statements, maybe a group of statements that are taken to be true but without proof. So ano ba implication if they are taken to be true without proof? It means that these are fundamental truth. There are no truths or there are no other statements that we can find that will prove this statement. So para kumbaga, sila na yung pinaka-basis, no? Wala na tayong makita pang ibang statement na pwede makaprove na true sila. Yan yung axioms. And pag sinabi nating axiomatic, meron tayong limited number of statements that are assumed to be true without proof, and from them, we can derive the whole of mathematics. It means that from them, we can prove other mathematical states. Okay? Yan yung ibig sabihin ng axiomatic statements. Okay? Okay, so let's have again another question. What is a theorem? Theorem. So theorem is, unlike axiom, na accepted natin na true, pero walang proof na true siya. Hindi natin ma-show na true siya. Pero feel natin na true siya. Theorem naman is a statement that is a mathematical fact, and we can actually show that, or we can actually prove it that it's true. Yeah? Maybe using the axioms or using other theorems. Okay? Thank you. Okay. So we will describe the different types of geometries based on the axiomatic system. It means that even geometry itself, meron siyang axioms. Or it can be built on axioms or tinatawag nating axiomatic systems. And then for different set of axiom or different axiomatic system, we can derive different geometries. So iba-iba. There is no only one geometry, but we can have many geometries depending on the axiomatic system that we are using. Okay? So yan yung number 2. We can differentiate the types of geometries based on the axiomatic system. Okay? And the last one is we will discuss the implications of the different geometries. So tatlo yan siya, dapat at the end of the course or at the end of the module, ito dapat yung mga ma-achieve nyo as our learning outcomes. Okay? Okay. Nung pumunta ako sa Greece, sa atin, no? Of course, nandun naman sa Greece naman yung simula yung axiomatic development, no, ng mathematics. Ito yung picture ko nung I was in Parthenon. So I just use my own picture kasi baka makapiright tayo. Itong picture na lang ginamit ko. Behind me is actually the famous Parthenon. But it's also in Greece where we can find yung isang school o university doon. At the entrance, nakalagay yung statement na ganito. Let no one enter who is ignorant of geometry. So you see what's the importance of the premium that ancient Greek put on geometry. Kumbaga, if you study geometry, you are considered as a learned person. No? Or required siya na matutunan mo ang geometry. And we can see this actually sa mga works na na-produce nila. For example, yung Parthenon dyan, no, makikita mo talaga na mayroon siyang this is built on someone who has knowledge of geometry. Yung pagka-arrange ng mga columns, yung pagka-construct ng structure, makikita mo talaga na yung mga architect na gumawa nito, may knowledge sila ng geometry. And not only sa ancient Greece, but also in Rome. No? So ito yung picture na kinuha ko when I went to Rome, sa Vatican Museum. Nandun yung famous Sistine Chapel na ginawa ni Michelangelo. So I took this picture when I was there. So makikita mo doon sa ceiling, nandoon yung kumbaga fresco na ginawa ni Michelangelo. Makikita mo rin doon that Michelangelo have had a strong knowledge of geometry. Kasi yung mga patterns na ginawa niya, yung pagka-arrange ng mga figures, makikita mo talaga na meron siyang sinusunod na geometric principles for that. And this works kahit saan mo makita. If you travel, you look at the different yung mga structures, underlies them are geometrical patterns. And ganun ka prevalent, no? Or ka widespread you're thinking of a career in, ano ba yung course na anthropology kayo, di ba? Kahit antro kayo, no? Sabihin antro, wala naman masyadong math. But that's not true. Wala siguro masyadong equation. But math is not only about equations, but it's also about shapes and patterns. So when you study or when you apply your learnings, kung maging antro na kayo, most of your job or most of your task would be about identifying patterns, right? And identifying relationships. And maybe these patterns come in the form of shapes. Tama? So whenever there is a activity that calls calls for identification of patterns, that is already mathematics. Kasi yan naman talaga ang purpose ng math. To describe patterns. One of the purposes of math. Describe patterns. So yan yung example ko doon sa mga travels ko around Europe. Okay, so let's start with the word geometry. So we can actually get the name or the what geometry means by by studying the parts of the word, no? So it comes from actually dalawang words yan siya. Hatiin natin geo and metry. Okay. So yung meron actually yung siyang Greek counterpart, di ko lang maala kung ano. But basically it's geo and metry. So pag sinabi natin geo, when we say geo, there's always the idea of, for example, geology. What do you mean by geology? What do you mean by geography? Yeah? Geo actually means earth. Okay? Earth. Itong titirhan natin, this is earth. And metry means measurement. So the earliest form of geometry actually deals with earth measurements. So making sense of the patterns or shapes na nakikita natin dito sa mundong ibabaw, which is the earth. Okay? So maybe some of them are interested in measuring distances, right? Or measuring heights, or measuring widths or lengths. And also, people are interested in a movement of heavenly bodies. But how did they do that? They use Earth as a point of reference. Kaya yun yung geometry, okay? Or the Earth measurement. Okay? Now, titignan natin, ano ba yung study of geometry before Euclid? So, of course, prior to Tito Euclid, meron na rin geometry. Pero ano ba yung i-introduce ni Euclid that somehow differs from, kasi ginamit natin siya as a reference in time, di ba? In the study. So siguro, itong si Euclid meron siyang important contribution kung bakit siya naging point of reference sa study ng geometry, sa history ng study ng geometry. Namaya, ma-learn natin yan. Pero ano ba yung geometry before kay Euclid? Kumbaga, let us say, yung ating dean ninyo, si Sir Mong. No? Si Sir Mong, kumbaga, or si Sir Pago, naging dean siya at a certain point in time. We can analyze what was CHSS before Sir Mong and what was CHSS during and after Sir Mong. So ginamit natin siya as a point of reference in the history. Right? Same thing with Euclid. Okay. So ano yung geometry before Euclid? So siguro titignan natin yung mga civilizations natin. No? So yung mga Middle Eastern civilization, Babylonia. Saan ba yung Babylonia ngayon? Diba? Yun yung Iraq. But yung ancient Babylonia is actually a civilization yan siya. Okay? And for them, yung geometry involves the study of volumes in areas. They are more interested in applying geometry to study or to compute volume and areas. In fact, meron na silang ways na pag-measure ng, of course, it's easy to measure the area of a square, di ba? Or a rectangle. Pero mahirap mag-measure ng circle. Paano kaya yan siya ginawa? Na-achieve na yan ng Babylonia, and they actually have a estimate of the pi. Yung pi is, ang estimate nila is 3. No? Hindi siya yung eksakto, pero for practical purposes, no, okay na yung 3. Okay? And of course, meron na rin silang knowledge ng Pythagorean theorem. No, si Pythagoras yung Greek yan siya, di ba? Pero even before Pythagoras laid down his theorem, or mga tagasunod ni Pythagoras ay, let us say, na-discover nila yung theorem, meron na actually alam mga Babylonian about this Pythagorean. And aside from that, itong mga Babylonian, sikat yan sila sa as astrologer, or they study also yung movement ng mga planets, mga stars, yung zodiac sign, galing actually yan sa kanila, mga Babylonian. So that's why they have also knowledge or familiarity with angular distances. Okay? So they're familiar with the rising and setting of sun, motion of planets, and then solar and lunar eclipses. Okay? And another civilization is yung mga Babylonian. Mga Babylonian naman, Babylonian, Egyptian. Okay? They also have knowledge of how to compute for areas and volume. Itong popular Rhine papyrus or the Ames papyrus, ang book doon yan is about geometry and about formulas for computing volume and area. Okay? And then comes the Greeks. No? Yung Greek civilization. Andyan si Eratosthenes. So this is pre-Euclid pa rin, ha? Andyan si Eratosthenes, where he calculated the circumference of the earth. Na-calculate niya without leaving Greece. Andyan din si Archimedes. Kilala, wala naman hindi nakakilala ka Archimedes. Siya yung nag-introduce ng integral calculus. Unang-una, gumamit ng integral calculus. Although, at this time, hindi pa na-formalize. But, diyan nagsimula yung integration. That's how to compute volume of irregular shape. Paano ka mag-compute ng irregular shape? Madali lang mag-compute ng volume ng cube o ng pyramid or ng sphere. Pero, paano kung yung solid mo ay irregularly shaped? Tama? Isa nga sa kanyang popular is yung discovery niya ng yung eureka moment niya. Remember yung there was a king who was interested to know whether his crown is pure gold or not. But of course, the crown is irregularly shaped. Hindi naman siya cube, hindi naman siya perfect na pyramid or sphere. So, nag-isip si Archimedes paano niya i-measure yung volume na yun. So, discovered yung displacement, principle. Yung amount ng water na ma-displace, yun yung equivalent doon sa volume. So, yan si Archimedes. Of course, si Pythagorean theorem. Marami pa actually siyang mga na-lay down na mga math principle, pero Pinakasikat, ginagamit natin ngayon, si Pythagorean theorem. At of course, si Thales. Okay? At saka yung kanyang popular na Thales theorem. There are also other contributions of mathematicians before Euclid. Aside from geometry. Una-una yung irrational numbers. So irrational numbers is yung numbers that cannot be expressed as a ratio of two integers. Example dyan is yung pi. Pi is actually an irrational number because you cannot find two integer. Then form a ratio. Pag i-compute mo siya ay lalabas yung pi. Hindi. Pi is an irrational number. Another example is yung square root of 2. Yung square root of 2, irrational number din siya. Okay? And of course, yung golden ratio, yung ginagamit natin na golden ratio. Saan natin yan siya magamit or saan natin yan makikita, we will discuss later. And that was some of the things that before Euclid, some of the things that happened or some of the things that the people already know before Euclid. Now comes Euclid. Yung popular na sinulat ni Euclid is yung book. Tawag natin dyan is elements. Hindi yan element periodic table. At tinawag na siya na elements. And it's not only about geometry actually. Marami din mga mathematical facts dyan sa elements. Pero isa sa mga ganda nakasulat dyan sa elements, sinulat ni Euclid, is yung axiomatic development ng geometry. So, ang important wala ni Euclid is siya yung nag-introduce ng set of axioms for geometry. Okay? So, ano yung mga axioms ng geometry ni Euclid? First is, things that are equal to the same thing are equal is a statement. We accept this as true. Pero wala siyang proof. Pero pwede natin siyang example. An example na ito is not really true. Kumbaga. Sabihin natin, kayo, kamukha ninyo ang inyong mama. And ikaw naman, kamukha mo yung anak. Can we say na kamukha nung anak mo yung mama mo? Based on the axiom, yes. Okay? Yun ibig sabihin ng things that are equal to the same thing are equal. Okay? Second, if equals are added to equals, then the whole are equal. So for example, yung number 3, add equal siya sa number 3. Tama? Is equal to itself. Adan mo ngayon ng 2. Dapat yung 3 plus 2 first, saka yung second 3 plus 2, they should also be equal. Yan yung second action. No? Sa ating number system. Number 3, if equals are subtracted from equal, then the remainder are equal. Same thing yan sa number 2. Only that we consider here subtraction. Number 4, things that coincide with one another are equal to one another. So kumbaga ito yung yung kung mag-trace kayo ba, kung i-trace niyo siya, siyempre yung na-trace niyo pareha doon sa pinag-tracean. Yun yung ibig sabihin niya. And of course, the fifth one is the whole is greater than the parts. Of course, yan yung definition na usual na ginagamit natin that if we have to solve a problem, break it down. And if we solve the individual problem, then we're able to solve the whole. So a part of it is not equal. Or a part of the whole is not, the whole is always greater than equal. Pero sa set, meron na tayong nakita actually that the whole is not always greater than the part, because it can be that the whole is equal to its part. Yung sa set, yung infinite set, remember? So yung set of positive numbers, positive integers, yung 1, 2, 3, 4, 5, 6, 7, and so on and so forth, we know that subset of this is the set of even numbers, or 2, 4, 6, 8. But we managed to show that 2, 4, 6, 8, 10 has the same cardinality as 1, 2, 3, 4, 5. But 2, 4, 6 is part of 1, 2, 3, 4, 5. So hindi ito siya always mag-apply. Okay? But for this axiomatic system, we assume this to be true. Now we go to the geometry na. Ito na yung 5 postulates na binigay ni Euclid. First postulate, pwede natin sabihin itong axiom actually. A straight line can be drawn from any point to any point. So given 2 points, there's always a line that connects these 2 points. Yan yung axiom 1. Of course, there are some cases in reality where we cannot do that. No? Lalo na kung there is a blockage or there is space that separates between the 2 points. Of course, they cannot connect a straight line. But this also anchors on the assumption that space that we are operating is continuous. No? Means that these points can always draw a line between them. Second is, a finite straight line can be produced continuously in a straight line. So if we're going to have a line, then it extends forever. Okay? Number 3, a circle may be drawn with any point as center and any distance as radius. So any circle can be defined by a point and a distance from that point. So lahat ng points that is equidistant to that point in the center for a given R, then that defines a circle. All right angles are equal. Okay? Lahat ng right angle equal. Walang question dyan. And number 5, and this is also one of the controversial axiom of Euclidean geometry, is if a transversal falls on 2 lines in such a way that the interior angle on one side of transversal are less than 2 right angles, then the line meet on that side on which the angles are less than 2 right angles. Medyo mahirap ininin, but there are some equivalent formulation for this. Okay? Marami siyang possible formulation that is equivalent actually to the postulate. One is through a point P not on line L. So, meron kayong line, tapos magpili kayo ng isang point na wala doon sa line. There exactly. So, meron kayong line. And you choose a line, a point, not on the line. So, maybe this point. There exists exactly one line passing through point that is parallel to L. So, this is the line. When we consider this line, this is not the line that we're looking because this is not parallel to this line. In fact, like intersect siya. What we are looking is actually this line. Yeah. There is a line, there is a point, not on the line. And if we draw a line through that point, there exists exactly one of that line that is parallel to this line. Yan yung fifth postulate. And of course, from that fifth postulate, we can now, or from that set of postulate, we can now prove some statement about shapes. Okay? So Euclidean triangles have a total sum of the measures to be 180. Yan, 180 yan. Sum mo yan, 180. And we can also show congruency. So same side, same shape. Ang yan ang ibig sabihin ng congruency. Okay? Same size, same shape. Similarity naman is not necessarily same size. So, pag sinabi natin similarity, same shape lang siya. Here we see that this triangle is similar to this triangle. Same shape. This triangle is also similar. But they are not of the same size, so hindi siya congruent. Similar lang. So the fifth postulate, di ba, meron lang exact, dalawa kasing element yon. Yung exactly one line, and we can have this two, right? Kasi sinabi niya exactly. Pero kung more than one line, or walang no line, is that possible? Or can we develop a geometry where these two are possible? So people started to ask this question, what if there is no line? What if there is more than one line? Yeah? Yan na ngayon yung development ng other geometry. And the first geometry is yung tinatawag nating hyperbolic. There's another line through P parallel to L. So it means that there are 2 points, or there are, through a point P, not on a line, there exists at least 2 lines passing through point P, but parallel to line L. So ano ba ibig sabihin? So for example, if this is the line, no, these are all parallel lines. It means that they don't meet these lines. Kaya sa tinawag na parallel. Yun kasi ang definition natin ng parallel. They don't meet, lines that don't meet. Ha? But in hyperbolic geometry, it's possible that for a given line, there are at least 2 lines that pass through a point, not on the line, but parallel to that line. So ito yung example. Ito yung, for example, ito yung line natin. Merong point ito. This is 1. But we can also choose this point. And there are 2 lines that we can draw. But they are not, or they do not intersect this line. So parallel siya. So in that case where there is more than one parallel line, then that's what we call hyperbolic geometry. So how about naman the case when there is no line? And that is the elliptic geometry. So through a point P, not on line L, there exists no line passing through point P parallel to line. So if we have a line here, and we choose a point, then that line will always meet. No? There is always a line. So all line will always meet that line. Ito yung elliptic geometry. Okay? Okay, so we have learned 2 geometries, no? Or 3 geometries. First is yung Euclidean, wherein the fifth postulate, there's only one line. We have hyperbolic, where there is at least 2 lines, parallel, and there is also elliptic, wherein there is no line. Means that all lines will eventually intersect that line. Yan yung elliptic geometry. Okay? And usually that is actually on the surface of a sphere. The surface of a sphere forms what we call elliptic geometry. Ito naman is if we define the line as something that is not on the surface but on the side, then that is hyperbole. Or within the interior, then that is hyperbole. Projective geometry and topology. So, makita na natin na merong mga geometry pala that does not follow the fifth postulate. That leads us to geometry, projective, and topology. So, example dyan is yung axis of perspective. So, very important ito actually sa work of art. Okay? Because it gives us the illusion of distance. Okay? So, kung ikaw itong center of perspectivity, and you're looking at this point, and you're looking at this point, using perspectivity, you may now tell which point is nearer to you. So in this case, yung A is nearer than the capital A. Or small b is nearer than the B from the center of perspectivity. Ano yan siya na-apply? Yan natin itong painting. Okay? Itong painting na nasa left, wala siyang perspective. So hindi mo malaman kung gaano kalapit, kalayo yung building na yan dito. Mga tao. In fact, building halos the size ng mga tao. Pero using perspective gives you the idea of distance or the illusion of distance. That these people here or these structures here are farther from the structure here. So yan yung application ng perspective. And of course, it brings us to topology, which is the theory of space of points. And not only we look at shapes now as something that is similar or congruent, but we can also look at space that shapes that if we can deform that or we can do something on that space, on that shape, so that it becomes another shape, then that's the study of topology. Okay? So what are the possible things that we can do? So we say that two objects are topologically equivalent if one figure can be stretched, shrunk, twisted, or bent into shape as the other. Yan yung ibig sabihin. So for example, yung clay. Kung mag-ano kayo ng clay, pwede nyo siyang shape as a sphere, right? Pwede nyo siyang shape as a sphere by just stretching, twisting, or bending it. Pwede nyo siyang gawing cube. Tama? And in that way, we can say that they are topologically the same. Remember, yan lang ang pwede natin gawin. Hindi natin siya pwedeng bawasan. Hindi natin siya pwedeng dagdagan. It's only stretch, shrunk, twist, or bend. Okay? Then they can be considered topologically equivalent. So cut, di pwedeng putulin. No, we cannot cut it or we cannot put it into pieces. Hindi din siya pwedeng i-tear. No? Hindi din pwedeng punctuate or butasan or anything. No, not allowed. Hindi din pwedeng emerge yung various points. So example of that is yung popular na joke no ng sa mga mathematician that a mathematician cannot recognize between a cup and a donut. It's because they are topologically the same or equivalent, meaning you can apply this shrunk, stretch, twist, bend, so that from the cup, maging donut siya. Okay? So that ends our lecture on shapes.